even in deep space, there are things that look younger than they ought to be if the Big Bang story is correct. Evolutionists do not have a plausible explanation for the ultimate origin of stars. All their star formation theories either require stars to already exist or they require dark matter. The argument's not as strong as the evolutionists think it is. The other side has age issues too, but for some reason, the popular perception is they don't, that it's only creationists who struggle with these issues, and that's just not true. I've seen quotes by old Earth Christians say, "We know that light was traveling for billions of years." No, you don't. You don't know that. As Christians, do we believe that God knows more than we do?
We started off this series on the age of everything by discussing the rock record with Dr. Clary, as well as how different interpretations of scripture shape the way that people approach this conversation. So I'm super excited today to dive into this conversation with you regarding the universe and what it itself reveals about the age. So Dr. Hebert, jumping right in, why do you think the age of the universe is such an important conversation for creationists and Christians in general to have?
Well, because it gets back to the reliability of Scripture. When you look at the biblical description of creation, there is no hint of millions or billions of years anywhere in there. And I am personally convinced that nobody would ever get the idea of millions or billions of years simply by reading the Bible. When people try to insert that into the text, they are being influenced by outside sources. And I think if you just look at what Scripture says, it's very clear. If you look at the genealogical information in Genesis and throughout the rest of the Bible, I mean, the earth and universe are about 6,000 years old. So it gets to the question of the reliability of Scripture. Can we trust what the Bible is saying? And that's why this is such an important issue.
Yeah, I totally agree. So how old is the universe according to mainstream scientists? And also, how did they even get to that number to begin with?
Okay, they would say it's about 13.8 billion years old. And the number comes from what we call redshifts of these distant galaxies. And when you look at a galaxy, there's this very, very beautiful rainbow-like spectrum, but there's also these dark bands that we call absorption bands or absorption lines. And it turns out that if you look at those lines, you see that for a distant galaxy, they are shifted toward the red part of that spectrum farther than they would be if you're looking at something that's stationary. Okay. You can reasonably infer that those galaxies were moving away from us when that light was emitted. Now, and what the uniformitarians and what the Big Bang proponents do is they say, okay, the galaxies are moving away from us. They were closer in the past. You can rewind that backwards all the way till everything gets to a point. And that's what they do. They basically run the movie backwards, and of course, they believe that the expansion is accelerated, okay, over time. So it's not like a simple constant rate. Yeah. But when you run the numbers backwards, you end up with about 13.8 billion years. Now, what as a biblical creationist, I would say, is there is no reason that you have to run the movie all the way backwards. Now, I can understand why a uniformitarian would do that, because he doesn't believe there's a God. He doesn't believe God had anything to do with the universe's origin. He sees no reason not to run the movie all the way backwards. But you don't have to do that, and that's an unwarranted assumption. And let me give you an example. Like, if you throw a baseball through the air, okay, it's got this parabolic trajectory, okay? And you can have these equations of motion that describe the trajectory of the baseball. I mean, this is something you learned to do in your very first physics class. Now, that equation, okay, the equation is not smart enough to know that the ball left my hand. And it doesn't know that there's a floor that the ball can hit. So you can, in principle, use that equation, those equations of motion to prove, and I'm putting that word in air quotes, that the ball came up through the floor, and it took an infinite amount of time to get there, reached its apex, came down, went through the floor again, and it's going to go on that trajectory forever. Okay? You can prove that using the equations. Well, obviously that is a meaningless, mindless, blind application of those equations.
Yeah.
Okay? We have things called boundary conditions that are important. And there's no reason you have to wind the movie all the way backwards, okay? God could have created those galaxies with an outward motion for some reason. And we're going to talk about a possible reason for that in a little bit. A possible reason he might have created the galaxies so that they were moving away from the Earth.
Yeah.
Yeah.
Definitely possible.
So there's nothing about that forces you to rewind the movie backwards to a point, okay? And that's the very thing the Apostle Peter warns us about in his second epistle. He talks about these scoffers who are going to come, who are going to say that all things continue as they were from the beginning of the creation. And they deny creation, they deny the flood, and they deny that Jesus is coming again. And it's that uniformitarian thinking that leads you to deny the flood, but it also leads you to claim that you can extrapolate galaxy motions billions of years into an unobserved prehistoric past.
Yeah.
Yeah.
So when it comes to astronomy, how do we separate what scientists directly observe from the conclusions that they're drawing from the past?
Okay, it gets tough.
Yeah.
And this is one of the things I don't think people realize is that we are looking into the past, okay, when you see that light. The question is, how far into the past are we looking?
Yeah.
Most Big Bang proponents, even Big Bang proponents who are Christians, would say, oh, we're looking billions of years into the past. Well, that is not necessarily true. It's not necessarily true. And we can show that rigorously. But we are looking into the past to some extent, I think. The problem is that you start you have to disentangle all this stuff. Because the way we interpret what we're seeing depends in large part on what we believe about how long it took the light to get here. Mm-hmm. And depending on what assumptions you make, you could assume that light took billions of years to get here, or maybe thousands. And so it's especially tough in astronomy because we're not right there. We're not right there at those galaxies. Mm-hmm. Okay, we're looking at light that came from those galaxies, and you have to make assumptions about how long it took to get here.
Yeah.
And it gets tricky. And I think this is one of the reasons a lot of Christians jump to the conclusion the universe has to be billions of years old. And part of that is coming from a failure to differentiate what we're actually observing and what's interpretation. And in astronomy, those are a little bit harder to disentangle than they are in other fields.
Yeah. So kind of going off of what you just said, whether someone believes the universe is thousands of years old or billions of years old, like we're all looking at the exact same galaxies, the exact same stars. So we've talked about this previously, but worldview plays an important role as to how these observations are interpreted, which
Yes.
is exactly what you were just saying.
Yes.
But for you, Dr. Hebert, when you look at the universe as a physicist, what observations stand out to you the most when it comes to its age?
First of all, I can sympathize with the people who would look at the distant starlight issue and say, okay, it looks like it's got to be billions of years old.
Yeah.
That's, at first glance, that looks like a very strong argument. So I can sympathize with people who make that argument. But it's not as simple as everybody thinks. And even in deep space, there are things ages that are problematic for evolutionists and for Big Bang proponents. And this is something I want to clearly address. There is a misperception out there that it is only young age biblical creationists who have an age problem. That is not true. Okay. The evolutionists have an age problem too, in lots of areas. Okay, Big Bang proponents have age problems. Okay, they may not be as well known, but they've got problems too. How do you explain soft tissue in dinosaurs? They do not have a viable explanation for that. Now they're trying to come up with an explanation, but right now the only plausible explanation for soft tissue in dinosaur fossils is that the fossils are not millions of years old. That's it. Right now, that's the only reasonable explanation. And even in deep space, there are things that look younger than they ought to be if the Big Bang story is correct. And so we see a lot of that. You've got things like globular clusters, spiral galaxies. Those are some of the things that I think, even some exoplanets.
Yeah.
There are things about those things that are surprising to those who believe in billions of years.
Yeah. So we're actually going to talk about spiral galaxies next. So what are they? What is a spiral galaxy and how do they fit into this conversation that we're having?
Well, a spiral galaxy is exactly what it sounds like. It's a galaxy that looks like a spiral, looks like a pinwheel. It's basically flat for the most part, but it rotates. The spiral galaxies rotate slowly, but all the material doesn't rotate at the same rotational velocity, we would say. Okay, the stuff in the center is going around faster than stuff on the outside. And as a result of that, what happens is over time, those spiral galaxies the spirals actually start winding up. The spirals get tighter and tighter and tighter, and eventually the spiral structure will completely disappear. It'll look like just a featureless flat disk.
Wow.
So the thing is, you would start to see this winding up effect in just hundreds of millions of years. And I think you can reasonably say that by 1 billion or 5 billion years at least, probably sooner than that, but certainly by then, you wouldn't see any spiral structure. Okay. Yet they claim these spiral galaxies are much older than that. And so that is something that's problematic for them. Now they have been working on a way to explain that for a long time. There are these things called spiral density wave theories that they're trying to explain how the spiral structure can be maintained for a long period of time. But one thing that has become very clear in maybe the last 10 years or so is that all their computer simulations have what we call recurrent and transient spiral structure. In other words, the spirals seem to sort of spontaneously generate, okay, but then they disappear. And then you get more spirals, okay? Now, that by itself, you might say, okay, that sort of it's a draw, okay? Creationists could say, well, they don't last very long, but the evolutionists could say, well, we're seeing spiral structure, but it's not the same spiral structure that it started out with, okay? How do you tell the difference? One thing, though, that I think pushes the argument in our favor is that these galaxies also have magnetic fields. And some of these magnetic fields, you need a stable spiral structure for them. And that's the one thing these models can't provide. So I think this is probably still a valid young universe argument. It doesn't prove the universe is just thousands of years old, but it does suggest that these spiral galaxies are a lot younger than what they're saying.
Yeah, it seems that way. So you gave us a very good just overall conclusion and overview of spiral galaxies and how those point to a young universe. But I also want to jump into blue stars. Mm-hmm. I know you have done a ton of research on blue stars.
I have, but it's not published.
Oh, so we have something to look forward to.
Yeah. I've done an insane amount of research on this, yes. And this is something that's really been bugging me, yeah.
Okay, well, you're going to give us a little sneak peek today.
Okay.
So what do blue stars reveal and why are they even significant?
Okay. Well, first of all, you need to realize, here's the argument. The argument is the very hottest blue stars burn through their nuclear fuel in just a few million years, all right? So the question is then, if the universe is billions of years old, why do we still have blue stars? And so this is a great question. This has long been an argument for a young universe. Now, not all creationists agree with it, though. The evolutionists claim that new stars are being formed today. And some creationists say, well, maybe that's theoretically possible. So some would argue maybe we shouldn't use that argument. Now, here's the thing. Regardless of whether you think that's a valid argument or not, evolutionists do not have a plausible explanation for the ultimate origin of stars. The reason for that is all their star formation theories either require stars to already exist, or they require dark matter. And dark matter, nobody knows what it is. Nobody really even knows if it even exists. So they don't, the only way they can explain star formation is if stars already exist or you invoke something that we're not sure even exists to begin with. So the bottom line is they don't have an explanation for the ultimate origin of stars. Now the question is, are blue stars a valid argument for recent creation? And some creationists disagree and say it's not. I kind of think I disagree with that. Because there's two big issues here. And like I said, I've spent an insane amount of time on this. There's two issues. First of all, is it theoretically possible? The story is that you can have this collapsing gas cloud and stars can form from that.
But that hasn't been proven.
Well, it hasn't been observed. Okay, that's one thing. But the other sticky point is that this would take a long time. This would take a very long time. And evolutionists talk about newborn stars. The youngest age I have ever seen claimed for a quote-unquote newborn star is, I think, 10,000 years. Mm-hmm. The second youngest age I think I've ever seen is 300,000 years, okay? So you gotta understand, when they talk about newborn stars, we're not talking about something that was born yesterday. Even within their worldview, these things are thousands of years old. The problem is it's gonna take thousands of years. It's gonna take much more than 6,000 years for a gas cloud to collapse. So the question is, in a creation worldview, is there time for that? Because almost every explanation for distant starlight that's been proposed by creationists has deep space clocks today ticking at the same rates as they are on Earth. Mm-hmm. Now maybe, okay, you could have had them ticking faster during creation week, but once creation is over, they all have clocks ticking at the same rate. So the question is there time within a biblical framework for star formation to occur, even if it is theoretically possible? And I'm not sure that it's theoretically possible. I mean, even Neil deGrasse Tyson has said, he has said, if we didn't know that stars exist, frontline research could give you all these great reasons why stars could never form. And he's not even talking about the chicken and egg problem I mentioned earlier, like he's talking about other stuff. And I think there's a lot of creationists who are maybe worried. Maybe at some point we're going to see a star form, and they're worried that we're going to get egg on our face. Mm-hmm. But even the evolutionists admit it is virtually impossible for us to see it, because first of all, it's too slow. Like, even if you accept the secular story of star formation, it's not something obvious. Like, basically, when you have these protostars, supposedly, they're already glowing. They're already giving off light and heat even before they transition to full-blown stars. So it's not like this is something that's super obvious. And we've never actually seen a star form. We've seen stars blow up, but we have not seen a star form. And even the Big Bang proponents acknowledge we probably never will. So I'm a little worried that maybe we creationists are conceding too much by saying, well, maybe star formation can happen. I think that's a conversation we need to have. And the question is, does the Bible allow for it? The only way I can, if you look at Genesis 1, it seems to be saying God's creation of the universe was finished. It was done. The only way I could think that maybe you could have star formation in a biblical worldview, ongoing star formation, is if there was a cloud that was already collapsing at the end of day 4, and it was close enough to star formation, assuming it's theoretically possible that here, thousands of years later it actually happens. And God's ways are sometimes inscrutable, but would he do that knowing that that would give ammunition to those who want to deny him?
Yeah.
So I think this is a conversation creationists need to have. Are we conceding too much by saying, maybe ongoing star formation can happen? I'm not sure it can. And the other thing is, this is a successful creationist prediction. Okay, creationists say you should not see stars forming, but we've never seen it happen. We've seen stars blow up, but we've never seen stars form. We've seen lots of stars blow up. And I don't know any a priori reason that star explosions ought to be more frequent than star formation. Even the evolutionists would say the youngest stars are thousands of years old. So we're not talking about something that was formed yesterday. And the other thing we got to consider as creationists is that what they call a protostar, the Bible would probably call it a star. Any luminous object in the heavens would probably biblically be called a star. So even if you have something that they would call it a protostar, I'm not sure even that proves.
Probably just a star.
How do you define it? And so I think we need to have that conversation. But again, maybe I'm out in left field on this, but there are other creationists who disagree. They think maybe ongoing star formation can occur, but we've never seen it happen. The evolutionists admit we probably never will. And the question is it even theoretically possible? Yeah. Astrophysicists, they can make plausible arguments for different stages of the process, okay? But we've never seen the start. That's the most important part. It's kind of like origin of life, right? They're claiming, they claim you can put the fossils in this evolutionary sequence, but there's these missing key parts, okay? And I think it's kind of the same way with star formation. The most important steps, I think, are missing. They can make sort of a plausible story, and parts of the story they can explain, but can they explain from first principles how a star could form naturally? I don't think they can. For one thing, those calculations would be very hard. If you include all the factors like magnetic fields and pressure in the gas and all that, it's I don't think they've ever done it without making simplifications. So to just start from scratch with a gas cloud and show that you can go all the way to a star, I don't think they've done it. And so I'm thinking maybe this is still a valid young universe argument, but some creationists would disagree. And these are creationists I respect, but I do think maybe we need to be having this conversation.
Yeah, I completely agree with you. So you've told us a little bit about spiral galaxies and about blue stars and star formation as a whole, but another observation that you have actually brought into this discussion in the past is globular clusters.
Right.
So can you tell me a little bit about what those are? Introduce that topic to our audience right now.
Okay, globular clusters, they're beautiful if you look through a telescope. They're these clusters of stars, and they kind of look like celestial snow globes. The stars in the center are very dense. They're spherical. They look like globes, but the stars are very dense in the center, and as you move outward, they become less dense. But they're very, very beautiful. But they also rotate, okay? They're slowly rotating. And there are a number of things about globular clusters, probably about 3 or 4 things actually, that are problematic for those who believe in billions of years. By secular reckoning, globular clusters are among the oldest objects in the universe. They're 10, 11 billion years old, something like that. One of the problems that they have is that is the fact that you still see central rotation in some of these globular clusters. Now, I have to sort of set this up.
Please do.
Okay, when you're in the center of those globular clusters, the stars are pretty close together. And they're close enough that they can perturb each other's orbits. The gravity they exert on each other can nudge their trajectories a little bit. Okay, so if you have 2 stars, let's say, the stars generally are going around this axis of rotation. Okay, so let's say you have 2 stars that are going like this. They can perturb each other, okay? Like this star over here is pulling this one this way. This star is pulling this one this way, okay? And likewise, you got stars above and below those that are pulling them up and pulling them down. And so what happens is over time, that nice uniform central rotation in the center of the cluster gets randomized, okay? Now some of them are going like this, some of them are going like this, some of them are going like this. And so the outermost stars are still doing what they're doing, but in the center, that nice uniform signature is gone. And the problem for them is they admit that it should be gone in 10 to 100 million years or so. Well, then why do we still see this central rotation in at least some globular clusters? Okay, that's an argument that they're a lot younger than what we've been led to believe. Another argument has to do with neutron stars, okay? You have... when you have these supernovas, you can get a neutron star that gets kicked. And it's like a recoil. And some of these things are going quite fast, and they've run numbers And it looks like in a globular cluster, now remember, the globular clusters are supposed to be some of the oldest objects in the universe. So basically, if you had blue stars in there to begin with, they should have exploded a long time ago, turned into supernovas, and you really wouldn't expect too many stars to be forming today, okay? So what's left? Okay, so eventually, in theory, most of those neutron stars that got kicked out, they should be gone, okay? And you can look at the numbers they calculate, and the number of neutron stars that are in there that they've counted is way higher than what they would expect if the globular cluster was really billions of years old, okay? Now, they've got some ways to try to account for that, but I don't think they've got a completely satisfactory explanation. And this is called the neutron star retention problem. It's a well-known problem in astrophysics. And so that's another indication, I think, that these globular clusters are probably a lot younger than what they're claiming.
Yeah, that's a strong argument right there. Well, I want to switch gears just a little bit and talk about Earth's magnetic field.
Okay.
And how does Earth's magnetic field fit into the broader discussion about the age of the Earth and the universe?
Okay, well, first of all, it's a very strong young world argument. Do not let the evolutionists kid you. They claim that they've got this dynamo theory that can keep the Earth's magnetic field going for billions of years. The problem is it doesn't work. In fact, about 10 or 11 years ago, they quoted a geophysicist who said, we do not know how the Earth's magnetic field has lasted for billions of years.
Exactly.
We don't know. Now, and he even said, we know now less than we thought we did 10 years ago. Now, this dynamo theory, I mean, they've also got this giant experiment in Maryland where they've got this 3-meter wide dome where they're trying to actually generate a magnetic field that can sustain itself through dynamo action. And they were talking about this when I was still in graduate school. I remember a poster session about this at the American Geophysical Union in 2010 or 2011. Well, guess what? They still haven't gotten results. They're trying to show that you can get a naturally generated magnetic field that can sustain itself. This is like 16 years later, they still haven't done it. And I don't think they ever will. So what does that leave us? If it's not generated by a dynamo, what could generate the Earth's magnetic field? Well, all magnetic fields are generated by electrical currents. We don't dispute that. The question is, though, in order for it to be a dynamo, you need complicated current motions. You also need a liquid core, and the Earth does have a liquid core, okay? But if you look at historical measurements of the magnetic field, okay, going back a couple of hundred years, we can kind of figure out what the strength of the magnetic field was, and also the energy of the field. The energy of the field is the more important quantity, okay? And it turns out the energy, based on those numbers, is decreasing by about half every 1,400 years. Now, if you run those numbers backwards, just 20,000 years ago or 30,000 years ago, the current needed to generate a magnetic field, because it would be way stronger than it is now, okay? It's an exponential decay, so when you go even just a few tens of thousands of years back in time, the strength of the field and the energy of the field becomes dramatically greater. Even just going back 20 or 30,000 years, the field is so strong that the current required to produce it would generate so much heat it would melt the Earth's crust and mantle.
Wow.
So that is, and that is a strong argument that it can't be that old. Now, they will say, oh, well, the Earth's magnetic field can flip directions. And we don't dispute that, okay? The Earth's magnetic field has flipped. The problem is that causes you to lose energy even faster. So that really doesn't help. So they don't have a good explanation for how the Earth can have a magnetic field after thousands, over billions of years. Now, we think, okay, you can have an electrical current that can decay over time, and you could still have a magnetic field after 6,000 years.
Wow.
Okay, so it's not a problem if you believe in a young universe or in a young world, but it is if you believe the Earth is old. And so also it's a strong argument, I think, Well, certainly that the Earth is young. And it turns out you can make similar arguments for other bodies with magnetic fields, and you can show that they have a hard time explaining their magnetic fields if you believe in the billions of years. So this turns out to be it's a very strong argument for a very young Earth. Now, I will admit, most young universe arguments, the way these young universe arguments work is that basically what you do is you look at some natural process that's going on, the rate at which it's going on, and to do this argument, we try to be generous to the uniformitarians. We make assumptions that they would agree with, and you run the numbers and you show that you get a maximum possible age that is incompatible with the Big Bang story. Right. Now, in most of these cases, I will admit, these ages are in millions or billions of years, but they're still too short to fit the secular story. But in this case, the Earth's magnetic field, you're getting a number that is much lower. We're talking tens of thousands of years. And that is a very strong argument that the Earth is very young. And if the Earth is that young, I think it's a good bet the solar system is too, and probably the rest of the universe.
I would have to agree with you right there.
Yeah, so now we'll get into some of the other arguments for an old universe, but the Earth's magnetic field is a very strong young Earth argument.
An incredibly strong argument for sure. Wow, you just enlightened my world a little bit. There's some things that you said that I had absolutely no idea about, so that was really cool. But let's dive into some new discoveries now.
Okay.
So over the past few years, the James Webb Space Telescope has given us some of the clearest and deepest images of the universe that we've ever seen.
Right.
So can you give us some background on the James Webb Space Telescope and what those images actually tell us?
Basically, the telescope is designed to see farther out into space. It's mainly looking in infrared, so it can see things that the Hubble can't. And we can see some very distant objects that we could not see. I mean, you can see a lot of distant stuff with Hubble, but you can see even more distant stuff with the James Webb Space Telescope. And we're seeing galaxies that are problematic for the Big Bang, okay? Not because they disprove that the galaxies might be moving away from us, but because by secular reckoning, those galaxies should not exist. Because remember, they think that when you look through a telescope, you're looking back billions of years in time. So when we see the very most distant galaxies, they would argue that we're not seeing those galaxies as they are now. We're seeing them as they were shortly after the Big Bang. So by secular reckoning, some of these really distant galaxies, you're seeing them as they presumably would have appeared just a few 100 million years after the Big Bang. The problem is they shouldn't exist because you need time to form stars and you need time to form galaxies. For instance, just 20 years ago, NASA was claiming that the first stars formed about 400 million years ago. Well, they now have galaxies that they found with the James Webb Space Telescope that by their own reckoning would have had to have existed maybe 280 million years after the Big Bang. And the problem for them is most of them would say the stars came first. So now you've got galaxies existing hundreds of millions of years before when, according to them, just 20 years ago, the first stars even existed.
Yeah.
So they're getting pushed up against the wall because they don't have time for these things to form naturally, even if you assume that it's possible. And another problem they have, you have the same thing with these supermassive black holes. You're seeing supermassive black holes. They think these things take like 1 billion years to form. And yet you're seeing some of them are in these distant galaxies, and they're by their own reckoning, okay, by their own Big Bang reckoning, these things are existing hundreds of millions of years after the Big Bang. They shouldn't be there. And they will tell you they should not exist. So those are some things that are really causing trouble for the Big Bang. And this is what I mean when I say people are under a false impression that it is only biblical creationists who have age issues. It's not.
No.
The other side has age issues too. But for some reason, the popular perception is they don't, that it's only creationists who struggle with these issues, and that's just not true.
Yeah, that's the only argument that I ever hear.
Yeah,
For creationists' view of a young Earth.
Yeah.
So, Dr. Hebert, what is another young universe argument?
Okay, one of them involves exoplanets. You know, we have found planets that are orbiting stars outside our solar system. And I think the number right now is around maybe 6,000 confirmed exoplanets. Now, this isn't true for all of them, but some of these exoplanets look relatively young. And what I mean by that is they are in the process of being destroyed. Like you have some of these, they call them ultra-hot Jupiters. They call them Jupiter exoplanets because they're about the same mass as Jupiter.
Okay.
And they call them ultra-hot because they're in very tight orbits around their host stars. And they're so close, they're super hot or ultra hot. That's why they call them that. Well, in some cases, the atmospheres of these exoplanets are basically being vaporized. They're losing their atmospheres. In some cases, the actual rocky crust is also being vaporized. Okay, not just the atmosphere, the crust itself is being vaporized. That's how hot it is. That's how close it is to the host star. Now, you say, okay, so what? Does that necessarily disprove billions of years? Maybe not, but here's the thing. Big Bang scientists, Big Bang astronomers, old universe astronomers have continually, over and over again, said, oh, it's so surprising that we see these things because, you know, if they're that close to the star, they're circling the drain. Their orbits are going to decay. They're going to spiral into that star within a few million years, okay? The problem for them is that in their worldview, that's like an eye blink, okay? A million years sounds like a lot of time to us, and it is, but in an old universe view, that's very quick.
Yeah, it is.
So they're constantly expressing surprise that we're lucky enough to be seeing all these exoplanets that are in the process of being destroyed and which can't last much longer. And so the fact that they're surprised by this, I think, is an argument. They're not expecting it, and you know, and in a creation view, why could God not create some of these exoplanets that close to begin with to their host stars? I mean, they could have been decaying since creation. And what's, you know, they're so surprised by this, they will often say things like, well, it must have migrated in from farther out. Somehow it got here. They just can't accept it at face value. Okay, this thing is in the process of being destroyed. It can't have been going on for too long, and it doesn't look like it's going to go on for much longer. So that seems to be a priori evidence of relative youth, okay?
Yeah.
So they are constantly saying, oh, that's amazing, we're so lucky to see this. Well, if the universe is just 6,000 years old, it's not luck, right? Okay, these things could have been decaying, their orbits could have been decaying, they could even be vaporizing since creation.
Yeah.
Okay? There's no reason this could not have been going on for 6,000 years.
Definitely not. So the next major topic that I really want to talk about is the whole distant starlight thing. But I have an important precursor question before we dive into that. So how far away is 1 light year? How do people measure that?
Okay, well, it's not so much that you measure it, it's that you define it. It's the distance traveled by light in 1 year, and it's about 6 trillion miles. And the bottom line here is we creationists do not dispute that the stars and galaxies are very far away. There's a simple geometric method called parallax where you can figure out how far a star away is just by, if you look, you can see, you know, when you squint and you look at your finger, it goes back and forth. You can do something similar with stars, and I forget the exact number, but it's valid out to maybe a few thousand light years.
Okay.
Now, when you go beyond that, there's other methods they use to establish the distances that build on that. But the bottom line is that as creationists, we don't dispute that many of these galaxies are millions and even billions of light years away. So that's not an excuse we can use to explain distant starlight. Okay, that leaves that off the table. So we still have an issue to explain. Yeah.
Yeah. Well, there have been several creation models proposed to explain that distant starlight. So what are some of those ideas, and where do you think that conversation stands today?
Well, there's one idea has been that maybe the speed of light was faster in the past. Another idea is that the Bible uses the convention that it simply assumes that when you see the light, that's when the event happened, and it treats it that way. It ignores the actual time it took for the light to travel. And I've tentatively endorsed some of these in the past, but right now because of all this work I've been doing on this book, I've done a deep dive on this. The only model that I feel like is really credible right now, the only one I feel comfortable endorsing, at least partially, is one by a creation physicist named Phil Dennis. And his is not as well known as other creationist models. But basically what he does is he shows that you can take the same equations used by Big Bang astronomers to describe galaxy recession, and you can use it to get even the most distant starlight here in 6,000 years. Mm-hmm. Now, it's not a complete explanation. Okay, there's a couple of issues. Well, first of all, let me get back to something. One of the things that's a key element of his model is he believes that God created these galaxies like he created a shell of galaxies around the Earth, but he created them so that they were moving faster than the speed of light away from the Earth. Okay, superluminal velocities. And I know what some people are going to say. Oh, you can't go faster than the speed of light. Well, yes, you can. The only question is, how can you do it? Because there are galaxies out there that everybody agrees they're receding from us faster than the speed of light. Mm-hmm. The typical explanation is that that's because space itself is expanding. Now, Phil Dennis disagrees with that, and I do too. That's if you think about that, that's kind of a esoteric claim. But in special relativity, you can't go faster than the speed of light, but in general relativity, you can. So he argues that God created these galaxies, but he created them so that they were moving super fast. And he shot them away from the Earth. Then he immediately created another shell of galaxies. And these don't have to be perfect shells. They can be kind of fuzzy. We're not necessarily saying that the galaxies have to be these nice, perfect shells of galaxies. Okay, it can be a fuzzy shell. But he's creating these shells, shooting them outward. And I have to admit, I've had people come up to me at creation conferences and say, well, why couldn't God just make the galaxies closer to begin with? And I sort of blew that off. But it turns out that's part of his solution. Now, it turns out you've also got to use general relativity. Okay. Just putting them closer to begin with by itself doesn't work. But if you combine that with general relativity, you can get the light from the most distant galaxies, the ones that we are now just seeing with the James Webb Space Telescope. You can get that light here in 6,000 years. Wow. You can. And it's using rigorous physics, and I don't really think there's much anybody can do to dispute it. Now I want to make it clear, there's so much I've got to say here. I don't consider myself a relativity expert. Now, I'm a physicist, but I do not consider myself an expert. But what's cool about Phil Dennis's model is that he's found a way to explain it that it is accessible to a lot more people. I have had a cosmology class. Okay, so I'm familiar with these, what they call the FLRW equations that they use to describe galaxy recession. And what Phil does is he takes those same equations, but he chops off the Big Bang. Okay, he says, okay, the galaxies are moving away and they were closer in the past, but we're not going to extrapolate everything to a point. Remember, boundary conditions matter, okay? There's nothing that forces you to say, I have to run everything all the way back to a primordial beginning 13.8 billion years ago. So he has God creating the galaxies some distance from the Earth, shooting them, and when he creates them, they're already moving super fast, superluminal velocities. Shoots them away. And by the way, the time for this to happen can literally be no time at all. He creates another shell, shoots it out, creates another shell, shoots it out. And eventually, you've got a universe filled with stars and galaxies. And you can rigorously show the most distant starlight can get here in 6,000 years. Now, that's the good news. The bad news, there's some bad news though too.
Okay, tell me about it.
The bad news is that it only works for galaxies that are like pretty far away. Once you get within the Milky Way galaxy or close to the Milky Way galaxy where the things are kind of clumpy and the galaxies are closer together, the solution technically is not valid. Okay, so it's only an explanation for the very most distant starlight. The other problem is it can't get the light here in 24 hours, as best we can tell. And yet Genesis 1:16 seems to demand that. And so I'd say I don't think it's a full explanation. And we may not figure it out. It's a tough problem. It is a really tough problem. So we can get the most distant light here in 6,000 years, but getting it here in 24 hours, that is a really tough problem, and I don't think we're there yet. And if the Lord Jesus comes back before we figure it out, I won't be surprised. It's a tough problem. It's a very tough problem. And so I can understand why some people would say this is a very strong argument for an old universe. But even so, it's not as strong as they think it is. I've seen quotes by old Earth Christians say, "We know that light was traveling for billions of years." No, you don't. You don't know that. And Phil's model proves that. It proves that most distant starlight we can see can actually get here in 6,000 years. So it's not a full explanation, but the question is, as Christians, do we believe that God knows more than we do? Is the Lord's arm too short? And I've heard pastors use distant starlight as an excuse to disbelieve God's word. And I'm going to tell you, as a physicist, I would not dare do that. No. I mean, he knows more than I do. He knows a lot more than I do. He knows a lot more than any of us do. And he's literally all powerful. So even if we have not figured out how to get that light here in 24 hours, he is capable of doing it. And, I have this mental image. I think it's so silly now I can understand the evolutionists saying this.
Yeah.
But for a Christian to say, I can't believe in recent creation because of distant starlight, I think it's silly. I got this mental image where on day 4, God creates the stars and he says, okay, I can't do anything for another 13.8 billion years till the light gets here. So I'm just going to sit here, not do anything, twiddling my thumbs, so to speak, while we wait for that light to get here. And then I'll move on to days 5 and 6.
That's pretty silly right there.
Do you really think an omnipotent, all-knowing being needs to do that to get distant starlight here? No. So I'll admit, we don't have a full explanation that I'm satisfied with, at least. But the argument's not as strong as the evolutionists think it is.
Yeah. Well, there are so many Christians out there who do believe in most of the Bible, but not that the universe was created in one literal week, or like we've been talking, that the Earth is only 6,000 years old, despite the genealogy record. Many old Earth Christians interpret both scripture and astronomy completely differently. So in what ways do people argue that astronomy provides some of the strongest evidence for an old Earth? I know you just talked a little bit, but is there anything else?
Well, the distant starlight issue is one of them.
Yeah, definitely.
Another one is you've got processes in deep space that look like they require lots of time. Mm-hmm. Like, for instance, you've got some supernova remnants that look like they've been expanding for more than 6,000 years. You've got these things called superluminal jets. The biggest one they've ever seen is 23 million light years long. Well, so presumably it's got to be at least 23 million years old,
right? So
on and so forth. You've got things like that. Now, Phil thinks that you can explain that using the fact that material can travel faster than light. But we haven't actually done it. Okay, that's something that creationists would need to work on. So, I can understand why somebody would look at deep space and say that's a strong argument for an old universe, and I can sympathize with that. But you got to look at the big picture. Okay, you can't just partition reality. Okay, when we're talking about origins, you need to be looking at everything. What's the best explanation for the origin of life? What's the best explanation for the water-deposited rocks and fossils we see all over the world? What's the best explanation for the fact that you have accounts, flood accounts all over the world, hundreds of them, in people groups that had these traditions even before missionaries got to them. What about all this evidence of youth in our solar system? And there's a ton of it. What about these deep space objects that look younger than they should be if the Big Bang is true? When you look at the preponderance of evidence, I think biblical creation is hands down the winner. Okay, you can't just partition reality and say, you have to look at the big picture. And I think when you do that, when you look at the big picture, it clearly favors biblical creation.
Yeah. So what would you say to someone who's watching right now who is truly undecided about whether the Earth is young or old, or what sort of research would you encourage them to?
Well, first of all, I'd have two different responses. For a Christian, I would ask them, do you really believe the Bible, and do you really believe God is all-powerful? Because if you do, why not believe what he wrote? Why not believe what he told us, okay? If you say you're a Bible-believing Christian, then you need to take God at his word. Now, if you're not, I would say you need to look at the big picture. Just like I said earlier, if you're not a Christian and you want to know where we came from, you got to look at everything. You've got to look at, all right, what's the best explanation for the origin of life? What's the best explanation for the design we see in living things? I mean, you look at the human body, there is no way that came about by accident. Okay, the engineering of the human body is, if you'll pardon the pun, light years beyond anything we could come up with. I mean, one lowly cell in our bodies is more sophisticated than a city. When you look at the big picture, it really does favor biblical creation. I mean, in my own research, something I've been working on for quite some time now, I'm finding all this evidence that's already been published that fossil creatures were living much longer than they are now. Well, that makes perfect sense in light of what the Bible says about people living to be hundreds of years old before the flood. If the people were living that long, it's a good bet the animals were too, and we're actually seeing that in the fossils. So basically, if you're a Christian, I would appeal to Scripture and say you need to admit that God knows more than you do, and if he says he did it in 6 days, you ought to take his word for it. And if you're not a Christian, I say if you sincerely want to know where we came from, and you look into it, you're going to find that the evidence is strongest for biblical creation. Okay, now I'm not saying we got everything figured out. Okay, distant starlight is not something we can fully explain at this point. But I think if you look at the big picture, we clearly have the stronger argument.
Yeah, I totally agree. Well, thank you so much, Dr. Hebert, for being here today. And I think you said it best. You said that we need to take God at his word. And that's exactly what we're doing. And that's the message that we're trying to show our audience as well. So
we have a creation astronomy club called Day 4 that meets here at the Institute for Creation Research every third Saturday of every month except for December.
I can add a link to that in the
video.
So
if you want to come out, learn about astronomy, I highly recommend it. We meet in the Discovery Center. You don't have to pay money to get in, but it's free. Just come in the door and you learn about astronomy. You get tips on using telescopes. You learn more about how astronomy confirms what the Bible says, and if you're in the DFW area, you might seriously consider coming on out to it.
Yeah, hopefully we'll get to see some of our viewers there. That would be incredible.
Yeah.
Throughout this series, we've examined different lines of evidence that speak to one of the biggest questions in science. How old is everything? We've explored geology, looked at different scripture interpretations, and now we've examined astronomy and cosmology from a young Earth creationist perspective. Today, Dr. Hebert walked us through the evidence and observations that has led him to conclude the universe is far younger than the billions of years commonly taught in school. Whether discussing spiral galaxies, globular clusters, distant starlight, or recent discoveries from the James Webb Space Telescope, we've seen that the same observations can often lead to very different conclusions, depending on the assumptions and worldview brought to the evidence. Dr. Hebert, before we wrap up today, what is one thing that you hope viewers will take away from watching this episode?
I hope they will realize that the evidence for a young world and young universe is a lot stronger than they've been led to believe. And it is not, the Big Bang people and the evolutionists, they have plenty of age problems, but for some reason they don't get the publicity that the apparent problems we have get. And but creation, biblical creation, is a viable scientific contender with the evolutionary story. And that evidence is getting stronger and stronger all the time. And it grieves me that so many Christians are running away from biblical creation when the evidence is stronger than it's ever been. And it keeps getting stronger every day.
It definitely is. You can partner with our ministry by joining our members and patrons community using the link in the description below. Their names are scrolling on the screen right now. And as always, Dr. Hebert, one of our viewers does have a question for you, so get ready for this. In approximately what year will the Earth's magnetic force field be too weak to sustain life on Earth? This was asked by Nat Weeks, one of our viewers.
That's a good question. I haven't run the numbers, but I think we can safely say the Lord Jesus is going to come back before then, so don't worry about it.
Good. That is such a great response.
Yeah.
Well, thank you so much for answering that for us, Dr. Hebert. And thank you, viewers, for joining us. If you've enjoyed these conversations, be sure to like, subscribe, and leave a comment. And share this episode with someone who's interested in the age of the universe discussion. We'll see you next time on the Creation Podcast.